Hello everyone. This is Professor Gautam from Sai Vidya Institute of Technology. I welcome you all for today's session. In this session, I am going to discuss about IZOD impact test. Before starting this today's session, I express my sincere thanks to virtual lab developed by Ministry of Education under the National Mission on Education through ICT, and also our sincere thanks to NITK, IITs and NITs. Now we will start today's session with virtual lab. Okay, the objective of IZOD impact test is to find the impact resistance of mild steel and cast iron. The apparatus used in this study is impact testing machine. Now, before starting the test, we have to select specimen for we need to conduct IZOD impact test. In this lab, I am going to show how to conduct IZOD impact test for cast iron. And these are all the dimensions of the cast iron. Length of the specimen will be 75.3 mm, breadth will be 9.3 mm, depth will be 9.52 mm, and depth of notch what we created here is around 5 mm. Before starting the test, we have to check for friction loss adjusting pointer to 164 joules. Now I will release the lever here. Okay. And the loss of energy due to friction, it has recorded as 2 joules. We have to place the specimen like this so that notch is facing towards hammer. We'll move on to the next step. In the next step, I had placed my specimen here and the notch has been faced towards hammer. So now I am releasing the lever and total loss of energy during transit of hammer is recorded as 4 joule. So friction loss is around 2 joule. Therefore, energy failure for the specimen is around 4 minus 2, that is equal to 2 joule. So here observations noted are initial energy of the rammer is 164 joules, average loss of energy due to friction is 2 joules, total loss of energy during transit of hammer is 4 joules. Therefore, energy for failure of specimen is 4 minus 2, that is equal to 2 joule. Okay. So we are going to repeat the same steps for the another trial using different specimen. So here same cast iron specimen is used having the length of 76 mm, breadth 9.4 mm, depth 9.46 mm and depth of notch is around 4.46 mm. So I placed specimen here and I am releasing the lever, and here total loss of energy during transit of rammer is recorded as 9 joule. Friction loss is around 2 joule. Therefore, 9 minus 2, that is equal to 7 joule. It is an energy for failure of specimen. So the same observation had recorded here. In the trial number 3, I took one more sample having the length of 75.3 mm, breadth of 9.3 mm and depth of 9.52 mm and depth of notch is 5 mm. Again, I kept the specimen in an impact testing machine. I am releasing the lever now. Now total loss of energy during transit of hammer is recorded. Again, it is 9 joule. Their energy loss because of the friction is 2 joule. Therefore, energy for failure of the specimen is 9 minus 2, that is equal to 7 joules. So just I had written all the values in a table. Loss of energy due to friction is in all the trial it is 2 joules. Loss of energy during transit of hammer, it's in the first trial it is 4 joules, and in the remaining two trials it is around 9 joules. Therefore, by deducting the friction loss, in the trial number 1, it is 2 joules. In the trial number 2, it is 7 joules. And again, in the trial number is 7 joules. That is an energy for failure of specimen. If I took the total average of these trials, the average energy for failure of the specimen is equal to 5.33 joule. And this is how you have to conduct IZOD impact test. Thank you guys. We will meet in the next session with another experiment.